Hey everyone, this is Dr. Walker. In this video, I'm going to go over the guided example from video 221 on parallel plate capacitors. It's going to be a quick video just using the equation that we just learned in the video. Let's look at the problem. Calculate the area of one plate of a parallel plate capacitor having a capacitance of 1 farad if the plates were separated by a distance of 1 millimeter. Please try to do this problem by yourself, and then pause the video, and when you're done, unpause it and let's take a look. So we are given the capacitance of 1 farad. Let's write down all of our givens. Capacitance is 1 farad, and then the distance between the plates is d, 1 millimeter. So we're going to convert that to meters by dividing by 1,000, so 0.001 meters. It says calculate the area of one of the plates. So the equation that we just learned is the capacitance equals the permittivity of free space times the area over the distance. All we have to do for this problem is get the area by itself and then plug and chug the numbers. The permittivity of free space, that was a constant that we just learned about in this video. The value of it is 8.85 times 10 to the negative 12. And then it does have some units, see, Coulomb squared, newtons, meters squared, but all of the units will cancel out so that you will be left with meters squared for the area. To solve for area, we're going to multiply both sides by d and then divide by epsilon. So c times d divided by epsilon, that will give us our area. And let's go ahead and plug in those values. Capacitance is 1, distance is 0.001, epsilon is 8.85 times 10 to the negative 12. And what do we get when we plug all of these numbers in? We get 1.13 times 10 to the 8 meters squared. So you're always supposed to look at your answer and make sure that it makes sense. Does this area make sense? How big is this area? This looks really huge to me. I actually looked it up, and the area of, so this area, if you convert it to miles squared, it's about 44 miles squared. And just to compare, Greenville, North Carolina is about 30 miles squared. So this is really, really huge. So it's not a reasonable number, but we didn't actually make any mistakes. The purpose of this problem was actually to let you know that you're not going to find a 1 farad parallel plate capacitor because the plates would have to be this big if there were, no other modifications made to this capacitor. So yes, we did it correctly, but a capacitance of 1 farad is not going to be a reasonable number for parallel plate capacitor. We're usually going to see capacitances in microfarad, or even picofarad or nanofarad, but we don't usually see farads if we're dealing with this type of capacitor. That's all for this video. In the next one, we'll see, what is a way to increase the capacitance of a capacitor, because we definitely don't want to increase the plates by that much in order to get a big capacitance. I will see you then.